You're about to listen to the Complete Developer Podcast, the podcast by coders and for coders about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. Welcome to another episode of Complete Developer Podcast with your host, Beardman, and the Boy Wonder.
Oh, lovely. I was wondering how you're going to work that in.
Well, if you follow me on Facebook, Instagram, Twitter, or Snapchat, I had to trim my beard. Well, I didn't have to, but I feel that some of the issue I've been having with job hunting has been because the long, kind of scraggly beard, as awesome as it looks, especially when I dye it white and wear a red suit.
Yeah.
I just think that...
Not to the job interview, though.
Depends on the job.
There is that.
But yeah, so I still have mine, though, whereas Will completely erased his.
Yeah, I trimmed... I got a haircut pretty short and shaved the beard off, and I'm keeping it...
It's like you reformatted your face.
Yeah, I kind of did. It's all right. Your beard did kind of exceed... You exceeded Stallman.
Yeah.
I don't know if anybody's familiar with Richard Stallman, open source advocate, takes a lot of very extremist positions that seem to turn out right. Given enough time, it's like, okay, maybe this dude isn't an extremist. Maybe he's just right and I'm not, but he kind of takes a while to grow on you. But yeah, he had a pretty extreme beard, but my beard was longer and so was yours.
Yeah.
And so there was a certain point where you're like, okay, I look like too much of a web developer.
I was trying to look like a web developer because that's the kind of jobs I'm trying to get, but I didn't look like a web developer looking for a job. Now I just look like Jonathan Franks. At least that's what I should look like because that's what I told the barber I wanted to look like.
Yeah, and I look like...
Wesley Crusher.
I look like Mark Hamill 10 years after Return of the Jedi. That's about right.
All right. So what have you been fighting this week?
Well, the new Gantt Software Systems website is stood up in Hexo. It's not live yet. There's a few things I got to fix. One thing too is I want to get the deployment completely automated before I deploy it all.
Yeah.
Before I regularly do it. And there's a few little things. I got a few bits of text I got to change more than anything. Not stuff that, and you built it. Beej took it once I had all the podcasts moved over. And while I was gone on my trip, Beej converted the rest over basically. So, that's set up and it looks pretty good. There's one or two little CSS issues that I noticed, but not, I really had to look pretty hard to find them, because I was actually trying to find problems.
What was it? I'm curious what slipped past me.
Like on the highlights on the menu, when you hover over it and you have the screen set to a certain width, the menu pops up and down very slightly in height by 2 pixels.
Yes.
Yeah, it's that kind of, it's that little, I know how I screw things up and I know that I taught you a lot. So you probably screw up the same way. So I know what to test for. That's going, and I'm back, from my Vegas trip, and I'm working through my action items, trying to get things going for the rest of the year. And my teeth are hurting. I apparently have been clenching my jaw at night, and I have this pain in my
TMJ.
right below my ear. And of course, you went to the whole osteopath thing, so I asked you about it, and it does kind of present a lot of the classical symptoms of TMJ. I don't know why I'm grinding my teeth though. I have less stress right now than I had for the last 2 years.
I told you it's because you don't have the weight pulling your jaw down.
Yeah. The weight of my beard. Legit. I don't know what else it could be, but, it's hurting pretty bad right now. So if my voice kind of fades off a little bit, that's why. It's because my face hurts.
Not because we have brand new microphones and you have to lean into it now.
Well, I really don't have to lean into it. I've got it further back, closer to my face.
That's true, because the stands are really nice.
Yeah, but you can hear me gulp beer. So
we could hear you gulp beer before. I just cut that out.
Okay. Well, that's cool too.
So I've been obviously on the job hunt. had a phone interview today, which I took notes on after the fact. I thought I'd be rude to take notes during the interview, but it was a 50-minute interview, and I wrote down a lot of the topics that we discussed, and Will and I are going to go over those, but we have an upcoming episode where we're going to go through a mock interview, and don't know how far in the future that's going to be. We're hoping we can get...
That's a nice way of saying Will hasn't sent the required emails to set that up yet.
We're hoping we can get a special guest on that we'll announce later. But yeah, we're going to do this, and they're going to do a mock interview with me and then critique me.
Yeah, at least that's the plan currently. This may change.
Yeah,
depending.
It may be me critiquing them.
Well, no.
No,
it won't be that. It'll be more of a we could also do one where I interview you and then discuss what the problems are, and then the guest may be something completely different. Yeah,
that's true. I mean, but for those of you in a similar place to me, I actually listened to I listened to Code Newbies podcast today because it comes out on Mondays, so I listened to it on the drive here. Their guest was talking about getting a job, getting that first developer job.
It's hard.
Yeah, it is.
Like my upcoming book has got like at least one chapter devoted to just that, because that is one of the most difficult things to pull off. Like it's a phase change in your career.
Yeah, it is. On that note, I want to announce something that we've kind of been throwing around. It started off as a podcast idea, and then it was going to be a blog. And I think we finally found what we're going to do with it, and that is called the Junior Developer Toolbox. Basically, we want to invite everyone to join a community of junior developers and more senior mentors helping each other out. We're going to have blog posts about tools and tricks and techniques. There will be a forum for asking questions to more senior developers or fellow junior developers that may know the answer.
Well, sometimes the senior devs need to ask junior stuff too.
That's true.
That's a good way to prove your expertise as a junior developer. And the other thing too is, like, if you're in this industry long enough, you start to develop blind spots. Mm-hmm. Because like the group I came up with, we kind of had the idea that mobile wasn't a thing. And that's obviously been proven inaccurate.
Well, when you first started, mobile wasn't a thing.
Yeah. My first job out of college, I worked with a guy that was developing a Pocket PC app. And because it was a Microsoft stack, they built a lot of things fairly similar to other stuff I'd worked with. And so we kind of went through some of that. But yeah, I mean, mobile was just not a thing. Pocket PC 2002, 2003.
I remember those.
Was not, they were awful. It's like, let me bring the blue screens to my phone. That's a great plan. And so the mindset then was mobile is really not going to get anywhere. Like, you didn't have a whole lot of touch screens. You didn't have, you had smaller and smaller screens. Everything was getting shrunk down. There's just a lot of stuff that it took a lot of senior devs a while to really turn around and look and go, hey, mobile matters. And I think it's very easy to develop blind spots because you run into stuff that's true until it isn't. Mm-hmm. And so, like, this is an opportunity for junior devs as well, insofar as like showing some expertise and getting contacts. So
what really kind of, I guess, galvanized me is the interview that I had today. I realized that I knew a lot of the concepts that I was being asked about, but I didn't know the terms.
Yeah.
And so I decided to put together a course for those of us that are autodidact or self-taught developers. It's kind of going to cover some of the common terms. Like, a lot of us know the concepts and we use those concepts, but didn't take classes and so may not know the terms that are used.
Yeah, it's like and we're going to talk about this here in a minute, right? When we get into design patterns.
Yes. That's why I'm announcing it for this episode.
Yeah, because that's that's a problem I face as a senior developer. It's like I've used all of these, but like nomenclature doesn't matter. It's like, can you apply this or not?
Yeah. And, we're going to do a course. As part of the course, we're also going to cover interview questions, common strategies that you're going to need to know, and some problem solving skills for interviews, like whiteboard problem solving skills. So with that said, let's roll that glorious music. This week, I have something, it's something that I'm going to build over this summer as a Christmas present, or maybe even birthday present for my nieces. And it is the $20 portable Raspberry Pi game console. There's lots of Raspberry Pi retro games and game emulators out there. This uses the Raspberry Pi Zero, which is the $5 really small Raspberry Pi with several cheap parts to basically build a little almost Game Boy type thing for playing retro video games. Of course, like I said, it uses the Raspberry Pi Zero, 2.4 inch 240 by 320 display, a lithium ion battery, prototype board, charging circuit, micro USB breakout, and 3 volt to 5 volt converter. And when you put it all together, the total cost is about $20, $19.86. You're going to need some wire, some basic soldering tools, and kind of some of the adapters and dongles that come with the Pi Zero. But most of us already have this stuff. I will be recording the progress of building this on my Snapchat, which is something I've gotten into recently because of one of my new favorite podcasts. It's become number 4 on my list of listen to every week, and that is the Sean West podcast. But if you don't already, you can follow me on Snapchat, and my username is bowtiebeej, or you can go to my website where you can get a link to my Snapchat and take a picture of it, and that's bowtiebeej.com. So, what are we talking about this week?
Well, this week we're going to start a introduction to design patterns, because this comes up a lot in interviews, all the way from intro level up to whatever the heck I am. But basically what we're going to do is a 4-part series looking into object-oriented design patterns. Obviously, there are design patterns for functional languages. There's design patterns for, procedural type stuff.
There's design patterns for specific languages. I found some that were specific to Java when I was writing up the notes for this.
Yeah, well, I mean, and there's also language idioms. Mm-hmm. So like the way, Ruby does things, and the way like the Ruby community does things, or the way the Python community does things. Yeah. There's certain structures, I guess, that they put around things that everybody knows that that's what this is supposed to be. Yeah, exactly. And yeah, so you'll see there's kind of a gradient between idiom and design pattern. Mm-hmm. And so the way that this is going to be structured, we're not going to do these back to back like we've done in the past. So over the next 2 months, we'll hit all 4 episodes. Yeah. And so we're going to talk about the 3 different sets of patterns: creational, structural, and behavioral. And kind of this first episode is going to be an introduction to the whole concept, where it came from. And then in each of those episodes, we're going to break down the set of patterns and talk about each particular pattern in that set. Yeah. And the intro is more of a, like you said, a breakdown of where all this stuff comes from, but also kind of how you apply them, because it's very easy to do this wrong and to become a pattern Nazi. Oh, yes. I mean, like, I can visualize the faces of all the pattern Nazis I've run into in my entire career. And that's also not good. Like, that's not better than not having design patterns. Mm-hmm. It's a good bit worse. Yeah, that makes sense. And so to start us off, I have a quote from sourcemaking.com, and it states,
In software engineering, a design pattern is a general, repeatable solution to a commonly occurring problem in software design. The concept for design patterns comes from a book written by a group called the Gang of Four back in 1994. It was titled Design Patterns, Elements of Reusable Object-Oriented Software.
Yep.
And the four authors were Gamma, Helm, Johnson, and
the other guy whose name starts with a V that nobody seems to be able to pronounce in our social circle.
Yeah, I was going to ask you how to pronounce it. So
yeah, I need to really find that online. We probably ought to put a link in the show notes and be like, here's how you pronounce his name so that you don't sound like a goober like we do.
Yeah.
But basically this whole thing of, okay, it's reusable object oriented patterns. The best way I think about design patterns is it's like, okay, I need like the architectural equivalent would be like, okay, I have a room and I want to have a roof over it, like where everything's dry. And then I need to be able to get in and out. I use a design pattern called a door.
Yeah.
Right. Like these are fundamental elements of how you construct software. Like there's no magic here. It's these things just kind of come out of use. Like you figure out, initially you hang a sheet or a tarp or an animal hide over a hole in the wall. And eventually you start figuring out, well, that lets rain in and it flaps and it's, in the wind. And so like I can put a piece of wood and then that's okay. But then I got to move it. So I'm going to put some hinges on it. And then eventually you get this thing that's like every modern door, right? It's a complex solution to a problem that evolved from a simpler working solution.
Yes. And a lot of these ideas do come from the architectural community. Yes.
And there's actually a law for this. And I can't remember the name of it off the top of my head.
So while Will's looking that up, the kind of the basis for design patterns is to program to an interface, not an implementation. And if they favor object composition over inheritance.
Yeah. The whole idea though really comes from, it's analogous to Gall's law. That's Gall with two L's, G-A-L-L.
Okay, yeah. I know that one.
It's the idea that complex working systems evolve from simpler ones.
Yes.
Like that's what you got to remember with design patterns. It's not that, hey, this working system is kind of like a theological construct that you must obey. It's a thing that worked that evolved from something else. And so you have to figure out where you are on the scale of that.
That makes sense. Yeah. And these are used to kind of create a common platform for developers. Also, they're used in creating best practices.
Yeah, just having an understanding, like instead of having to explain the whole thing about how the system works, you can say this is this, and you can categorize it. Mm-hmm. And then everybody that knows that pattern has a rough idea of how the thing works.
Exactly.
In just a couple of words.
Well, that reminds me, I had an interview, I guess about 2 weeks ago, and it was right around the time I started working on this outline because originally this series of episodes was one episode. And it was a requested episode by one of our listeners. Actually, I think two of our listeners requested it.
Yeah.
Separately. But, so I had designed it as one big overview of the design patterns and, there's 23 of them. That's just too much for one episode. And I write long episode notes. So
yeah, it was like I opened the file up and it's just too much. And it is a cornerstone of what we do, but it just can't be done in an hour to actually really describe it. So
that's why we broke it down. But what I'm getting at is when I was writing it, I wrote it all out at once. But that interview, the interviewer asked me a question and I answered by talking about design patterns. And his response was hilarious because he said, I had not thought of it that way, but I'm impressed you even know what that is as a junior developer.
Yeah.
And I explained to him about the podcast. I was like, yeah, I'm working on this episode that was requested by some of our listeners and everything. So haven't heard back from him. So fingers crossed. Here's hoping.
Yeah.
Some of the benefits that you get out of using
Divine patterns.
Divine patterns. There
See, this is what I'm talking about. No, sorry. We're going to totally leave that in because that's funny.
That is.
Because, a lot of people they do almost treat it with a little bit more reverence than it deserves. But the idea is that this speeds up development because it allows quick information sharing and structural sharing. Like no architect sits there and tries to think about the hinge structure on a door. And, like there's standard sized doors and there's standard sized hinges because they're building something more complicated. Like the door facilitates what they're doing, it's not the end goal.
Well, what I like about it is you and I are .NET developers, but we can have a conversation with a Java developer or a Ruby developer about the structure of our code because they're going to know the same object-oriented design patterns.
Yeah. And I steal stuff from Ruby developers all the time, ideas. And Microsoft basically stole ideas from Java.
That's so true.
For .NET. So
they're also tested and proven paradigms. So it's not, these are patterns and paradigms that have stood the test of time.
Yeah. And they're still around because they actually work.
Yeah.
Versus they work in academia, which those are two completely different things.
Yes, exactly.
And they also tend to be kind of generalized solutions, sort of abstracted out from the environment in which they evolve.
Yeah. And that's what gives them that standardized communication ability is because they've been abstracted out. You and I can have a conversation with, friends of ours that are Ruby developers talking about the exact same thing in different languages, but because we know the same design patterns, we can have that back and forth and we can learn from each other.
Yeah. It makes it easier to reason about things too, because you have expectations, about what you're going to be dealing with. And because you have those expectations and because those expectations are met by that design pattern, you can focus on the actual problem at hand versus the low-level implementation details.
Yes. Yeah,
so
exactly.
It's effectively an abstraction for the way you abstract things.
Good way of putting it.
It's a meta abstraction.
So meta.
Meta.
We are totally the hipster podcast.
Yeah.
Which makes us not hipster by calling us hipster. Anyways, so getting into the details of this episode, kind of covering the basics of what each set of patterns are. There are three types, which I mentioned earlier: creational, structural, and behavioral design patterns. And the creational have to do with instantiation mechanics.
Yeah, that word is so hard to it just does not, that word rolls off the tongue like a square block.
That word is very difficult to say after your second beer.
It's difficult to say regardless. But the idea here is that instead of, with creational patterns, the idea is that instead of every consumer of a class having to know how to build an object, like by passing a whole bunch of elements into its constructor, it's like, get me one of those. Mm-hmm. And this is the whole thing behind, dependency inversion, an IOC container type stuff is like, hey, I don't want to create this thing. Just get me one. It's the same thing you do, by the way, when you go to the grocery store and you buy a pound of beef. You don't start with a calf.
Yeah. The creational patterns are designed to make it easier to create objects.
And to also change the way that you create them.
Yes.
Because if you have to change it and there's, 10,000 references to the creation function for that object, or the constructor or what have you, you're not going to change it.
Exactly.
Because you're going to have to regression test all these other things. Mm-hmm. And so it's basically a way of abstracting the creation to the point that you can deal with it in the same way that you deal with everything else with objects.
Yeah. And all of these patterns within the creational design patterns have to do with creating classes and objects and methods.
Yeah.
Because you're creating ones that you're abstracting it out to create multiple. Next is the structural design patterns, and these have to do with relationships between entities.
Right. And a lot of these tend to favor things where you have two objects interacting. Instead of directly interacting, they interact through something else.
Yes.
Like an event sync or a proxy or a flyweight pattern. These things are put in place so that the objects that are in communication with each other don't actually have to know the intimate details of the other end of the conversation and whatever level this happens to be, so that
it makes it more interchangeable too, because
right, you're not screwing over the topology of your object graph this way, right? Like you can switch pieces out easily. It's interchangeable parts. I mean, this was a design revolution that Ford pushed through. Well, with the whole assembly line thing, this like interchangeable parts is a huge, like it's probably a bigger invention than the wheel if you get right down to it, as far as impact on human civilization. And we've got the same thing in our design structure for object-oriented programming, is we have pieces we can switch out. And the reason we can switch them out is because they're not tied together.
Yes.
Two things that are soldered together, it's a real pain to disconnect them. Whereas if there's a wire that plugs in both ends, that's a little bit more manageable.
Yes.
And so think of these patterns as the wire.
Mm-hmm. That makes perfect sense. And that goes along with some of the stuff that you've complained about in the past with
tightly coupled
code. Yeah.
Yeah. People that think the database, should be tied tightly into the website, even all the way up to the front end of the web, like to the JavaScript side of the site. It's like, oh yeah, this structure is exactly the same as a table all the way on the back end. It's like, that's great, but this doesn't work because now I can't switch anything out. Yeah. And I'll eventually have to.
I would think that doing that would be easy to code the first time.
Yeah, it really isn't even easy.
No?
Because
I've never done that, and I've never dealt with any code that had that, so that
it's very easy to reason about, but it's very hard to code because of it's unlikely that you're going to get to the end and actually be able to tie those pieces together.
Yeah. Okay. That makes sense.
Yeah. It's the same. I mean, it's the mindset of, hey, if I have to replace the carburetor in my car, I really don't want to replace the whole car.
Again, with carburetors.
Yeah.
I mean, I know you drive a newer car with fuel injection.
Yeah. But I mean, it's the same principle, right?
I'm picking on you, man.
Yeah.
Yeah. So the idea of the structural design patterns is to make it easier for entities, objects to work together.
Yeah.
And by abstracting that connection so that they have one place to connect to instead of having to connect multiple entities to multiple entities.
Yeah. Directly. Yeah. There's some sort of, there's some sort of topology there that allows pieces to be switched out without touching other pieces.
Yes. Yes, exactly.
Because you don't want to play operation with your design. You remember that game? Like where
I do remember that game.
The patient with a little thing, and you got to pull the piece out without hitting the deal that sets off the buzzer.
I always hit it on purpose because I like the shock.
Well, you would do well on some programs I've dealt with.
So the next set of patterns are the behavioral patterns, and whereas a structural had to do with the relationship between entities, behavioral patterns have to do with the actual communication.
Right. So like, to kind of recap, we had creational patterns that deal with instantiation. It's like, hey, how do I get the things I need?
Yes.
And then you had structural patterns that go, hey, what's the topology of the interaction? And you have behavioral patterns. It's like, what am I actually doing?
Yes. Yeah, exactly. And these are things like interpreters, mediators, chains of responsibility.
Yeah. Although some of those that bleeds over a whole lot into the structural pattern because a structural pattern has to be there for the behavior. Yeah.
I was gonna say there's a bit of crossover here, and they're divided up into these more for, I guess, for human understanding and for us, because it's easier for us as people to categorize things
and reason about just a particular subset.
Yes. Yeah. Rather than if it was just all one big blob.
Yeah.
So, and the idea here is with creational making objects easier to create. Makes sense. Structural makes objects easier to work together, and behavioral makes it easier and makes communication more flexible. So
but all these things are really about decoupling.
Yeah.
Like part of your app should not know the rest of your app more than it needs to know.
Mm-hmm.
And
it's about making it modular.
Yeah.
That's the whole concept of object-oriented programming, is that you have these objects that should be interchangeable. You can take them out and put them in.
Yeah. And it makes it easier to reason about what's going on.
Mm-hmm.
That's at least half the concept.
Yeah.
Because at some point, as we get into this, a lot of people that are pattern Nazis have a tendency to make things where they fit the patterns very, very well, but they're impossible to reason about. There's certain languages that are particularly well known for this. One of them rhymes with guava, and and
like I said, they have their own subset.
Yeah,
that I found, and we may do an episode in the future down the line about that, but again, that's going to be only for a subset of our listeners.
Well, Java kind of hit the scene and got really big right, not too long after this book was published.
Yeah. And
so they kind of caught that wave. And so a lot of things are very pattern heavy within the Java development environment. Now, of course, I say that coming from .NET, and we're not really all that much better at this point. We just talk like we are.
Of course.
Because it's pattern soup.
As I understand it, when the idea behind Java was one language, all platforms. The idea behind .NET was one platform, all languages.
Yeah. And now they're kind of going the other way because .NET's running on everything.
Yes.
Or they're trying to get it to run on everything, but everything runs on Java. So like you can get Ruby runtimes that are based off of Java.
Yeah.
There's a lot of, they've kind of crossed over and stolen ideas from each other. So
I think everybody should just drop all this stuff and program only in C.
Nah, they'll use Scala.
Scala, there we go.
Yeah.
Well, we're going to go for this. Let's just do straight up assembler.
Might as well.
Feel like the wizards we are.
Yeah.
Getting back on point. The last point we have for this introduction is to kind of review some of the critiques of design patterns.
And holy moly, can I rant about this? One thing that I see a lot is where they target the wrong problem. Mm-hmm. They go, okay, we need an adapter here. We need to, we need to have a mediator pattern. Oh, hey, let's put an event sync here. Right.
Yeah.
Or, there's a lot of this kind of stuff where it's like, okay, are there multiple things that actually need to be switched out here? Because I've seen classes that are very tightly coupled that talk to each other's interfaces, but they assume details about the innards of the class anyway. It's like, oh yeah, we're great. We put a pattern in place, or we've even got another class between us, but we're still tightly coupled across that.
Huh. Because
they go, oh, well, it's always going to be this other class at the other end. Like you're solving the wrong problem if you're doing this.
Yeah.
And it's also very easy to do things like I feel particularly like, a lot of your object relational mapping patterns are solving the wrong problem.
I can totally see that because the idea should be.
Well, it's like the database is another. I guess my big thing is that the database is another. The database is a different microservice living out in your architecture. It just happens to be written in SQL.
Yeah.
And a lot of people go, oh, I'm going to build an ORM and I'm going to have everything set up so that it can talk to the database and not really know anything about the database. But the entities that it returns are based directly on the tables anyway.
I have a very tangentially related question.
Okay.
Is it ORM or ORM?
Whatever way fits your tone of voice.
Gotcha.
Yeah. I mean, you'll hear it both ways. It's like URL or URL.
Yeah. Okay. Because I coming into the industry again, like coming back, there's a lot of things that I've read but not heard, having not taken classes on them.
Most people say ORM.
Okay.
But the idea here is that a lot of these folks will build these things that are essentially, and I can't remember what the pattern is called. I don't think it's one from this book. It's something that, is a derivative pattern, but it's basically the idea of I can call into the database and I can build up this object based off of what comes back, which is completely fine.
Yes.
Except for the fact that now, because of the way that I structured it, my stuff is very deeply tied into the table structure of the database. And it's like, okay, well, I made it easier to query, but at the same time, I made it impossible for the DBA to do their job. And it's really a case of I'm solving the wrong problem because I'm introducing a pattern that creates deeper linkage between what I'm trying to access and what I'm actually trying to do with the data versus something that introduces decoupling.
Okay. I see what you're saying there. Yeah.
And that's a very rambling, long explanation for something that's really a lot simpler than it seems. What I gathered from the argument that it targets the wrong problem is that the need for design patterns arise from using languages with insufficient abstraction. Yeah.
And that a lot of patterns are not needed depending on the language you're using.
Yeah. Well, some patterns for like memory management and things, if you have a garbage collected language, most of the time you don't use that. Yeah. So, and, again, languages sometimes make certain patterns obsolete. They also, a lot of times it's very possible to build up a pattern that really is just kind of dumb based on the language you're using. Like if you're using JavaScript and you're explicitly declaring things, sometimes you really don't need to, because JavaScript, you can edit the object on the fly. Same thing with Ruby. Any language that lets you dynamically alter an object and stick other methods on there it's going to be a very different structure.
Yeah.
If you even need the particular pattern in question.
That makes perfect sense. It seems that because this is designed for a style of programming, object-oriented specifically, that there would be things in some languages that were more useful. Some patterns are more useful in certain languages than others. And certain languages, by default, the way the language is set up, would not need a pattern because it's built.
Well, I'll give you an example.
Okay.
Lots of languages have a for each loop.
Yes.
That's an iterator. It's built into the language itself.
Okay.
At some level you may have to implement that if you make a custom, collection object or something. But for the most part, it's like, okay, I can enumerate this collection with a for each loop, and that's built straight into the language itself. So some of these patterns you're not even going to see because they're in the language by default. Another critique of design patterns that comes up for me is that it lacks formal foundations.
Yeah, it was kind of an ad hoc study.
Yeah, and I guess there's two thoughts here. One is that if somebody tries to define a pattern, they tend to use a lot of mathematical language that does not give you an intuitive grasp, sort of like most mathematics does, to be completely honest.
Yeah.
And so that's one problem. But the other problem is they go, oh, it's an adapter. Well, what do they really mean by an adapter? Half the time they mean an event sync. Half the time they mean, oh, it's a mediator, or it's a flyweight, or it's a very specific pattern. But it's like, hey, look, we're hooking this to this so that, we're hooking A to B so that A can talk to C without being entangled.
Yeah.
And, it's the same structural pattern, but we'll use the wrong word freely.
Okay.
So it's not very well, formally defined in a lot of cases, especially in most people's minds. And so we tend to lose the value of the communication because we don't have a accepted understanding. Like there's what's in the book, and then there's what people actually do, and those roads don't cross.
Well, we've talked about this with other things like, agile and waterfall methods. What's in the papers and in the books and what is done in practice doesn't exactly match up.
Yeah.
Because people change it to their situation, and then people learn that situation and go out and change it to another situation, and it kind of evolves, and it doesn't always evolve for the better.
Yeah. So, I mean, this is something to kind of bear in mind when you're having to talk patterns.
The other thing, though, is something we mentioned earlier with one of the benefits is that these, I guess, because they didn't come out of a formal study, they're more practical.
Yeah.
So it's kind of a give take. It's, the idea that there wasn't a formal study on developing these, that these came out of practical usage and, I don't want to say almost anecdotal.
Yeah. Well, it's stuff that people noticed.
Yeah.
Over time, and it was, hey, this structure arises organically from the miasma of coding problems that we have.
Yeah. Yeah, exactly.
And it's not that this structure is the structure. It's like, hey, this falls out. Mm-hmm. It grows like a crystal. It's like, well, it's the consequence of a bunch of smaller decisions that were made. It's not the decision itself.
Yeah, that makes perfect sense. Cause it's like, it's not, they set out to create languages and to create programming around these patterns. These are the patterns that came about from solving problems programming.
Right. I mean, it's evolutionary.
Yeah.
It's Gall's law applied. It's the idea that simple systems at work give rise to complex systems at work. Complex systems that are built from the start as being complex don't work. Mm-hmm. And, so this is the idea of design patterns is I'm naming the complex systems, not the simple systems that arose before them and that are probably still in existence.
Yeah. Yeah. Okay. I can see where you're going with that.
So it's like saying, here's all the species of ape. I'm not going to name the bacteria.
Yeah. Yeah. Okay. I can follow that.
Yeah.
You put it in biology terms, I can follow that.
Yeah. It makes a little bit more sense to think about it this way. One thing that I've also seen a lot with design patterns is it's very easy to get inefficient solutions. Yeah. Either solutions that the programmer cannot reason about within a reasonable amount of time because there's so many layers of abstraction, or more commonly, if you have high performance requirements, you can't abstract past a certain point. Like things get slower the more levels of indirection that happen.
Well, like we've talked about this with some of the other more technical episodes we've had where you've even said, if you're a systems programmer, just ignore everything else we have to say because it won't apply to you. But the majority of people, it does.
Yeah. And I mean, I can give an example from assembler, at least as it was when I learned it, which has been a little while. Yeah. Right. Like if I load a register, if let's say I've got the AX register and the BX register, and I know I'm dating myself by naming them that way instead of EAX and BX, but if I put a value in AX and then I go, okay, I actually want to clear that out, right? Mm-hmm. Well, the fastest way to do that, instead of going, I'm going to put 0 in that register, is to XOR that value with itself because I don't have to load the register with something else.
Oh, okay. Yeah.
And I don't know that that's entirely true with modern processors. And I know that most compilers will actually do that optimization. But, the fact is what is setting something to 0? It's functionally equivalent to XORing it with itself. Mm-hmm. But the latter is actually faster, even though it's harder to reason about.
Yeah. Okay.
And so it's this sort of problem. Like you have a trade-off on performance. There's some things that you can get away with slow performance on. Mm-hmm. There's other things you can't. Like where I work, we're having to deal with very large PDF documents. Some of, like there was one, I think that was like 130 something thousand pages of PDFs.
Holy cow.
And you start running into problems with like
we were having problems with a 9-page PDF on my mom's computer.
Right. I mean, these things like you load them up in memory and you're having to do a lot of really odd stuff to get everything in there because like the object space that is available, like the addressable space within that document is limited. And so you're having to do a lot of reuse. You're having to do a lot of really tight optimizations, and the code to do that cannot be effective with heavy abstraction. It just can't, because you're dealing with gigabytes of memory that you're having to blow through, and you just got to go as fast as you can. So always bear in mind that there's a trade-off. It's very easy to build something that's like, oh, this is perfect pattern soup.
Yeah.
However, it's massively inefficient.
Okay.
You want enough inefficiency so that you can actually reason about what's going on, because your brain and the processor don't work the same, but you don't want any more than that.
What that kind of goes along with one of the other things I found under this, which is the statement that well-factored implementation is better than just enough design pattern. Yeah.
Well, and you always bear in mind that your code is never completed. It's abandoned.
Yeah.
So you can build something that is good enough to get the performance gain or get the abstraction gain that you're trying to get without making it an academic spew.
Yeah. Yeah.
Because the latter, it just doesn't work. Like, you know, sometimes your team has to evolve. Like, there's other tactical and strategic decisions other than just the code that you're working with.
Yeah, that makes sense.
And it has to weigh with that. It cannot be by itself. If like that's your single issue, you're a pattern Nazi. And other developers are going to hate you. And when you're gone, they're going to fix your stuff where they can actually reason about it and perform it.
And the last critique that I found is, and by all means, this is not an exhaustive list of critiques. These were just the ones that...
Oh, you'll never find an exhaustive list. You'll find an exhausting list, but you'll never find an exhaustive list because there's always one more.
Well, these are the ones I kind of boiled them down to, like the major critiques. And that's that design patterns do not significantly differ from other abstractions. And in response to this, my attitude is, well, design patterns are a way of thinking about abstractions. They're not meant to significantly differ. They're meant to be how we understand abstractions.
Yeah, here's a rough way of how some dude made this work.
Yes, exactly.
That's what a design pattern is. And when it becomes something beyond that, it stops working, frankly. Yeah. And you'll start to see kind of similar topologies to most of your design patterns. Like in real life, like when you've coded object-oriented programming enough, like when you first wake up in the morning, you'll look around and you'll almost start visualizing things as an object graph when you're in that phase of like waking up out of sleep or going to sleep.
You mean the area where Tinkerbell loves Peter Pan?
No, like legitimately there are patterns.
You know the movie Hook?
Yeah. There are topological patterns of life.
Yeah.
That arise organically. And you'll start to kind of see very similar things outside of programming that are the same kind of deal. It's an organic, it's an evolution of things that worked in the past.
Yeah.
Right?
Okay. Because
you think about what is, let's talk about our team structures, right? Mm-hmm. You have a couple of people, you got, one person kind of in charge, and you got another person that's kind of the second in command, or, the go-to if this one's not there. And then you got a bunch of people kind of talking like a little cluster. What is that? Well, that's small unit tactics. That's military. That's hunter-gatherer tactics.
Mm-hmm.
That's a bunch of monkeys, roaming around in the jungle somewhere out on the savannah. Like, it's the same principle that has evolved from the previous ones. The reason it works is because it did evolve.
Yeah. And that makes sense. And like I said, this hasn't been an exhaustive list of critiques. And I will not have one in the show notes. There will be links to longer lists for you guys. If you
the guys that came up with this had their own.
Yeah, they did.
Take on it.
Since then they've even come out with some of these came from stuff that they've written. And personally, I think that's great. That was one of the things that I liked about some of the critiques was it was even the guys that wrote it said, hey, this isn't perfect. It's a way of thinking about things.
Yeah. Well, you've never come up with a reasonable meta abstraction about the way people reason about things until you've seen somebody use it wrong.
Yeah. That's kind of heady, but I get what you're saying there. Yeah.
Yeah.
So, quick review. We started off with talking about the Gang of Four, and they wrote a book titled Design Patterns, Elements of Reusable Object-Oriented Software. And what we're going to do is have 3 more episodes talking about each of the sets of design patterns, creational, structural, and behavioral. And then we kind of ended up the episode with talking about the different critiques. Some of the major ones, like Will and I both said, this was definitely not an exhaustive list, but just some of the big critiques out there. So before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, this relates to design patterns actually pretty well.
Awesome.
And it's the concept of knowing when to make trade-offs.
Okay.
Because that's what all this is. And we touched on it briefly before. It's the idea that, hey, I'm building code, but I'm not building code in a vacuum, which is how academia builds code. That's why academic code and understanding it is such a pain.
Yeah.
Is because it's developed under very, very different constraints that really don't work very well in the real world a lot of times. And so the idea here is just take the time to understand where your code is running, not just in terms of what other code components it's interacting with, but like the quality of your team, the runtime environment that you're going to live in, how smart your customers are, how easy it is to troubleshoot it, deploy it, etc. Because you can make an ivory tower solution that's absolutely beautiful and never runs anywhere.
Yeah. But
it's when it comes into contact with the other people. And I'll give you an example. I've worked on very, very competent, highly skilled teams that could do absolute pattern soup, and everybody on the team could reason through that stuff.
Yeah.
I've also worked on teams where things like callbacks were things people didn't understand. They couldn't do generic code or, like templated types in C++. Like that was past them.
Okay.
And when you build patterns, or when you use a pattern to try to achieve a particular result, you have to be cognizant of the fact that it also has to be consumable by your team.
Yeah. Okay.
And so you make a trade-off there. It's a similar thing with performance. You can put all the abstractions in the world in there, but if it's an operation to say, I don't know, copy memory from one location to another, and then you have a memory copying factory, you screwed up.
Would that be like an abstract factory?
Yeah, well, you'd use that to instantiate the memory copying factory.
Okay.
Probably. But like if you're doing that kind of thing, like just think about the trade-offs of what you're doing, because if your memory copying routine takes more memory to actually build the copying structure to do the copy versus what is actually in the memory that you're copying, that's probably not right. And so you have a lot of other constraints. And so it's just very important to make appropriate trade-offs.
Yeah.
And just, really think about that, and don't just think about it in terms of what happens on the coding side, because it's very easy to write dense, impenetrable code that you go, oh, I'm brilliant for writing this. And it's like, yeah, you're so brilliant that nobody else can maintain it. And now you can't go on vacation.
Oh yeah. I mean, that goes along with the concept of if you write your code at the peak of your ability, you by definition cannot debug it.
Yeah. Well, yeah, I forget who exactly said it, but it was something to the effect of debugging is harder than actually writing. I
was just kind of quoting what you said in a previous episode.
Yeah, I can't remember how I put it, because I just kind of throw stuff out, and
Yeah.
That's a trade-off I've made.
Yeah.
As it were.
I accredit you to that quote to you whenever I say it to people, but
it's probably not mine.
It's probably not yours originally, but I say this is where I heard it from.
Yeah. So that's what I got.
Titanfall.
If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at www.completedeveloperpodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Thanks for listening. See you next time.